All right. SOH CAH TOA. This is going to be a review from geometry with a little bit of new stuff in it. Okay. Isn't this the class where we were talking about SOH CAH TOA being the big word that you didn't know what it was?
He didn't know what it meant. We all know it.
Okay. Yeah, in one of the classes, I think it was this one. We thought it was the Indian chief in Pocahontas. Yeah, that was this. Okay, that's what I thought. Okay. So, SOH CAH TOA. The S in SOH CAH TOA stands for sine. The O and the H tell me that sine is opposite over hypotenuse. CAH stands for cosine is the adjacent over hypotenuse. And the TOA stands for tangent is opposite over adjacent. Okay. All that stuff is old. It should not be anything new. The right-hand side of this chart, however, is going to be new for most of you. And there's a typo on that side, so let's fix it. The bottom of the right-hand side should be this. So now, CSC theta, that is cosecant. Well, cosecant is just the reciprocal of the sine. So all we're going to do is take this fraction here and flip it upside down. So cosecant is the hypotenuse over the opposite. SEC stands for secant, and it is the reciprocal of cosine. So when I flip this fraction upside down, I get hypotenuse over adjacent. Now, before we do the tangent and its reciprocal, I want to talk about those four real quick. Okay, so I'm going to cover this up. Now, in my brain, I always want these two to go together because they both start with S, but it's not that way. The ones that are reciprocals, there's an S and a C, so a sine and a cosecant. This pair is also an S and a C. What's wrong?
I mean, it's just like the way you said that was like redundant, like there was no separation. You said they both had an S and a C.
Well, the top one, there's an S and a C for sine and cosecant. This one is an S and a C. My brain wants to pair both of the S's together.
Yeah.
But I've had to convince myself no. And so I think about S and C in each pairing. All right, now for tangent, the reciprocal of tangent, that is cotangent. This is the only pairing that actually makes sense to my brain. So when I take the fraction for tangent and flip it upside down, I get adjacent over opposite. Now, you can memorize the fractions for all 6 of these if you want. I don't. I never think, oh, the cosecant is hypotenuse over opposite. Never. I know those 3 because of SOH CAH TOA. I know how they're paired. So if I need the cosecant, I find the answer for sine and then flip it. Like I said, you can memorize it all if you want to. So now what we're going to look at are these special right triangles one more time. Actually, we're going to do it twice today. Once in this part and then again in the next part. So this is stuff we did before spring break. It was your bell ringer the other day. I need to see if you can go in and fill in the missing sides of these triangles, and then we'll put it up here and see how you did. Yeah.
Does that mean that
So are y'all doing these triangles? Sarah says no. Okay, when you get done, check them with mine, and then let me know if you have a question, and we'll go over how we got it. Yeah. These, where do they come from? Okay, so normally on a 45, 45, 90, your hypotenuse has a square root of 2 on it, but this time it doesn't. So the shortcut we talked about before spring break was take this side and cut it in half, which would make it be 1/2, and then just stick a square root of 2 on it. When I actually multiply those together, I get this. Anybody else?
Does that work for like odd numbers on the 45, 45?
Yeah, if it was an 8, you'd cut it in half and your answer would be 4 root 2. Yeah.
Can we go over the shortcut for the 30, 60, 92?
For the 30, 60, 90, your hypotenuse is always twice the short leg. So if I take 1 and cut it in half, I get the short leg is 1/2. Then I have to take the short leg times the square root of 3 to get the long one. So when I have 1/2 times the square root of 3, go ahead and multiply it, I get root 3 over 2. Okay. So now, these triangles all have 1 as the hypotenuse. Every time you see these triangles for the next week, week and a half, the hypotenuse will be 1. So these numbers you're seeing here, you're going to be using over and over and over again. So now, what we're going to do is we're going to take these triangles here and find the value for all 6 trig functions, for a 30-degree angle, for a 45, and for a 60. So what I want to do is I want to do the 45 with you. So there's my chart. And by the way, I copied and pasted the same chart here. So go ahead and fix that. So for 45 degrees, I want to know what the sine is. So first thing I have to do is find my 45-degree angle. Sine is the opposite over the hypotenuse. So all the way on the opposite side of the triangle from 45 is square root of 2 over 2. And I have to put that over the hypotenuse, which is 1. When you put anything over 1, you get what you started with. So the sine of 45 degrees is square root of 2 over 2.
Wait, what if it was any number except for 1? Would you still have to put it like over 1? Or would you put
No,
it
if it was another number, you would put it over that other number. You know, if we were not leading up to unit circle trig and you had a triangle that looked like this, and I asked you to find the sine of 45 degrees, well, your opposite is 7. Your hypotenuse is 7 square root of 2. Your 7s will cancel, leaving you with this. You have to rationalize it. And that's going to give you square root of 2 over 2. So it's going to simplify to the same thing, because the sine of 45 degrees is always square root of 2 over 2, regardless of what numbers are on the triangle. So before we go on to the cosine and tangent, let's take a look at the stuff we did on our hand the other day, when we talked about on your left hand. Which finger was 45 degrees? The middle one. So if I fold this here, I have 2 fingers above. That is the square root of 2 over the imaginary 2 that's in my palm, and I have a square root of 2 here over the imaginary 2 in my palm. Okay, we're going to learn what those are in just a few minutes, but that's all related to the sine, the cosine, and the tangent. I told you the other day that tangent would be on the back. So based on that, I've got the square root of 2 over the square root of 2 reduces to what? 1. Guess what our tangent's going to be when we do it down here? 1. Now let's go back to the triangle and see why it's 1. Okay. So if we do the cosine real quick, from this 45-degree angle, the adjacent is square root of 2 over 2. The hypotenuse is 1. So again, I'm putting root 2 over 2 over 1, and I get root 2 over 2. What's wrong, Natalie? Are you sure? So now for the tangent, from this angle, I want to do the opposite over the adjacent. So when I put the square root of 2 over 2 over the square root of 2 over 2, anything over itself is going to be 1, which is what we just saw on our hand just a minute ago. So now I don't need the triangle anymore for the right hand side, so I'm going to move my paper over. So when I want to find the cosecant of 45 degrees, I just want to take this answer and flip it over. So that gives me 2 over the square root of 2, but I have to rationalize it because I can't have a radical in the denominator. So multiply by root 2 over root 2. I get 2 square root of 2 over 2, and the 2's top and bottom cancel, leaving me with this. Anybody know what the secant of theta is going to be? It's also going to be the square root of 2 because it's the same work all over again. And for cotangent, I have to flip 1. What do you get when you flip 1? 1. Okay, so there you go. Now, what I want you to do is first we're going to work with that 30-degree angle. So we're going to take a look at this triangle down here. And go ahead and fill in your sine, cosine, and tangent. I'll give you just a minute and then I'll put mine up here and see how you did. And then we'll flip them and get the others. All right, so go ahead and check your sine, cosine, and tangent for 30 degrees. If you have questions, let me know. If you need me to just make it bigger so you can see it better, I can do that too. So when you flip 1/2, you get 2. When you flip square root of 3 over 2, you get 2 over the square root of 3, and then you have to rationalize. And the secant will be 2 square root of 3 over 3.
So you have to use the last step to flip.
Not necessarily. I mean, you have to take your answer and flip it. But I want to show you something with tangent. If I take this answer and flip it, I'm going to have to rationalize, right? But if I back up a step here, isn't this answer equivalent to this one? It's just not been rationalized. Okay, let me back up. Okay. Isn't this what the tangent is? It's just not in simplified form. Okay, so can't I take this and flip it, and that will give me just the square root of 3, and I didn't have to do any rationalizing. If I had taken this answer and flipped it and rationalized, I would still end up here. Okay? So you can do it either before or after you rationalize your answer. All right, so now we've got 60 degrees left to do. I'll get my triangle up here, see if I can get it up here at the same time. There you go. So see if you can do all of 60 degrees on your own. Alright, so here's the left-hand side if you want to check it before you flip to get the cosecant, secant, and cotangent. Okay, any questions about where those came from? All right, then go ahead and flip them. And here, I'm not going to recreate the wheel and do the work all over again. Didn't I already flip this in the previous problem?
Yeah.
Yeah, so I know what it's going to be. So the cosecant for 60 is going to be 2 square root of 3 over 3. When I flip 1/2, I get 2. Guess what I'm going to get if I flip the square root of 3? I get 1 over the square root of 3, which rationalizes to this.